Hey guys, this is the worksheet that we're going to be using today, and I'm going to go ahead and make a video and show you how to do some of these. So first, let's put down some of the rules that we learned yesterday in the PowerPoint. The first thing is first, it's percent to mass. So if you're given percents, you're going to convert or write them down as mass, okay? And this is empirical formula, and what it is it's the most reduced formula, okay? Most reduced. So in the notes, we discussed CH2O, and then there's C6H12O6. So you need to convert C6H12O6. If you reduce that, it becomes CH2O. CH2O would be the empirical formula, okay? That's the most reduced. And C6H12O6 will be molecular formula. When we come back from the break, we'll talk about the molecular formula. Percent to mass. So you're going to take the percents and write down as mass, and then mass to mole, divide by smallest, and multiply. So basically what I'm saying is that we don't want any fraction, okay? Multiply till whole. And there's an L there. I try to put it in. Okay, so here's an example. I'm going to quickly go through this example right here. It says percent to mass. So we're going to take these percents and just write them down as grams, which is what I did here for each of them. Then you're going to convert them into mole by dividing by their average atomic mass. You're going to get that from the periodic table, okay? Then it says divide by smallest. What we mean by that is we want to get the ratio of each of these in comparison to each other, okay? So we want to get the ratio of these, like how many moles of each of these are in this formula. So the smallest here is this one. It's 0.5 to 535. You're going to divide each of these by this, the phosphorus mole. And then you get 1.5 mole copper, 1 mole phosphorus, 4 mole oxygen. And I told you guys this yesterday, or it was in the notes as well. If you haven't got the notes, please go ahead and get the notes, okay? When you have a fraction like this, we want to multiply. For example, this is 1.5. You're going to multiply by 2 to round this to, or make it whole, okay? And that's what you need to do. If it was, let's say 1.33, you will multiply all of them, each of these by 3, because you can't just multiply one and not the other. That defies the algebra rules, okay? So if you're doing something to multiplying one variable, you need to multiply all of them, okay? Even. So we have copper is going to become 3 when you multiply by this 2. This is phosphorus is going to become 2, and oxygen is 8. And anytime you're going to see P2O8, you know that that's your polyatomic phosphate. So copper, here's the formula, copper 3, PO4 2. So take a look. This is the most reduced. You cannot reduce this any more. Now let's do the next one. A compound used to treat gout consists of 5.42% lithium, 65.65% carbon, 3.94% hydrogen, and 25% oxygen. And gout is basically a type of pain that people get in joints because of the accumulation of uric acid, okay? So let's take a look right here. We're going to take these percents and put them down as grams, just like this rule right here says, percent to mass, 5.42 gram of Li. And we're going to write them down just the way they're given to us, okay? You're not going to start out with carbon first. If it says lithium, then you're going to put down lithium, because in an ionic formula, your metal comes first, okay? So the next one is 65.65 grams carbon, and then 3.94 gram hydrogen. And I like to set them up all together, oxygen. And then you need to convert it into the molar mass, okay? All right, so notice I'm not doing O2. That's only Brinkel-Hoff, okay, when we're doing balanced chemical equation. This is a formula writing, okay? In this, you are given, look at this. Okay, here's the actual chemical formula. And I know we haven't done cyclic compounds, but that's the actual formula, okay, the whole thing. So you're just going to use O, don't use O2, okay? And the molar mass is 16 grams. Hydrogen, you're going to go ahead and use 1 mole. And you're going to put 1.01 gram hydrogen. Let me put hydrogen here, please. Use your, go ahead and put down your symbols, okay? And then this is going to be 1 mole carbon, and that's 12.01 gram carbon, okay? And then it's going to be 1 mole. I'm looking at the periodic table right now, because as much as you would like to think that I remember all these average atomic masses, I do not. All right. Then you're going to take, once again, if the number is on top, you know this is a division, 5.42 divided by 6.94. Feed it into your calculator, and I've already done that. It gives me 0.78098. Take 65.65 divided by 12.01. Notice your grams, these units are canceling, okay? Because we want the answer in, only the units are canceling. All right, so 65.65 divided by 12.01 gives you 5.4663. 3.94 divided by 0.01 gives you, let's see, 3.901. And then 25 divided by 16, 1.5625. Now, I hope you notice that I am not just writing 0.78 here. I carried at least 5 digits after the decimal, and that's what I need you to do because we want to get the right fraction, okay? Right factor. So that's what I want you to do. So now let's see which one is the smallest. The rule says divide by smallest. So let's see which one is smallest. It's clearly this one. We are going to divide each of these by the smallest number, which is right here. So 0.78098, 5.4663 gets divided by 0.78098, 3.901 gets divided by 0.78098, and 1.5625, 0.78098. This clearly is going to be 1. So when you put 1, you got to put down, notice here I put down mole copper. So you got to put mole Li. This is going to be 7 mole carbon. And this is going to be 5 mole hydrogen. And this is 2 mole oxygen. Notice there is no fraction here. There's no 1.5 like it was here, 1.33, 5.33. So we don't need to multiply till whole. These are already whole, okay? So now you can put together your formula. Li is 1, which is right here. Carbon is 7. Next thing is going to be hydrogen is 5 and oxygen is 2. And this is your formula. And notice it says, what is the empirical formula, which is right here, and the name. So you guys know how to do the names. You guys already have your polyatomics. Let me get my periodic table too. So we know Li is lithium. And if you look in the polyatomics, C7H5O2 is benzoate. So this is lithium benzoate. Okay. I'm going to make another video later on. Once I post this, I'll make another video doing a couple of more problems. All right. I hope this helps. Please go through, get your notes, go through the PowerPoint. Okay. All right.